2 over 2? Is that just like a different way of writing it?
That is, it's the same thing. Do you want to see how it's the same?
Yeah.
Okay, so if you have 1 over rad 2 like this, what you're referring to is something called rationalizing the denominator. So people, for some reason that's not clear to me, don't like the radical 2 on the bottom. So what they do is they multiply top and bottom by radical 2, which is like multiplying by 1, right? Like you can multiply by 1 for free. It doesn't change the number. So if you think about it, 1 times rad 2 is rad 2, and rad 2 times rad 2 is just 2. So that's how they end up with that. So in a traditional math class, students are taught not to have a radical in the denominator. But for me, I don't care. So I just leave the radical in the denominator. But if you rationalize it, that's fine.
Okay, I just wanted to make sure I wasn't doing something wrong.
You are not. You are not. Okay, cool. So hopefully you got something that looks like this. You could check your answers at home. So far, we haven't really looked at trigonometry yet, which is sine, cosine, sine, cosine, tangent, cosecant, secant, cotangent, right? But the nice thing about the unit circle approach is that it gives us the trig values. So I don't know where to write this. Maybe I'll write this off to the side here. Basically, the point corresponding to an angle, so point corresponding to an angle, the x value is going to be cosine theta, and the y value is going to be sine theta. Okay. So the way that we write this is we say, oh, the sine is going to be the y value. Cosine is going to be the x value. And last class, I taught you about the reciprocal identities, right? So remember that cosecant was 1 over sine, so that's going to be 1 over y. And cosine, secant is 1 over cosine, so that's going to be 1 over x. And just as a quick reminder, the way that I mentioned it to you was the co thing is always paired with the non-co thing. So like cosecant is not the reciprocal of cosine because they're both cos. They're kind of paired opposite. So sine and cosecant are paired together. Cosine and secant are paired together. That's an easy way to remember. And remember last class, I would refer to these reciprocal identities. So I forgot to write it, or I forgot to copy it. So this is going to be cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cosine theta. And remember, cotangent theta is equal to 1 over tangent theta. I seem to have forgotten the quotient identities here. Are they anywhere? Do you see them? Sorry. So there's some quotient identities. And basically tangent of theta is equal to sine of theta divided by cosine of theta. So if you look at what that means for us, sine of theta is y and cosine of theta is x. So this is just y divided by x. Cotangent theta is the reciprocal of that. So it's the exact opposite. This is cosine theta over sine theta. And that's going to be x over y. Okay. Is there any questions about this? No. Okay. So I have this unit circle here. We can answer these questions. If I want to calculate what's cosine of 2 pi over 3, what I got to do is I got to look at with the point where 2 pi over 3 is. The point where 2 pi over 3 is right here. If I want cosine, I want the x value. So the x value is negative 1/2. So I come here, this is going to be negative 1/2. Does that make sense? If I want sine of negative 5 pi over 6, what does this negative do? This negative means that we're going to go in the opposite direction. So if you went 5 pi over 6, I don't know if you can follow this. I'm starting over here, right? If I go, this is angle 0. If I go 5 pi over 6, I got to go all the way to this angle. So I got to go like this. The negative angle means we're going in the opposite direction. So if we go in the opposite direction, it should go here like this. So it goes this way. It's that angle. And if I want sine, I want the y value. So the y value is going to be negative 1/2. So this is negative 1/2 as well. Does that make sense to everybody? Is there any questions about that? All right, cool. Someone help me with this last one. This 17 pi over 4 kind of intimidates me. Does anyone have any advice for how I might want to solve this?
Does it mean that goes more than one round?
I think so, yeah. How do I figure out how many rounds it goes?
It goes 2 rounds.
It goes 2 rounds? Okay. How do you know that? I agree. How do you know that?
Because 2 pi is a 1 revolution, so I just times that by 4.
Okay.
And that's 8 pi over 4. And I just subtract that with the 17 pi over 4 to get 7 pi over 4 in the unit circle.
I like that. Yeah. So basically what our classmate is saying is every time you do 2 pi, you get a full circle. Okay. Now this particular student notices that our denominator is 4. So when you convert 2 pi into a denominator of 4, that's going to be 8 pi, right? So it's almost like this student is sort of saying, oh, we have 17 pi over 4. We're going to subtract 1 2 pi, which would be 8 pi over 4. Then we could subtract another 8 pi over 4, right? And when we could look at the remainder. So this first 2 pi over 4, 8 pi over 4, sorry, just means you've gone around the circle once. And then this means you go around a second time. So this totals to 16 pi over 4, right? So 17 pi over 4 minus 16 pi over 4 is equal to just 1 pi over 4. So this is what's really happening with this question. What's happening is we're starting here at angle 0. We go 8 pi over 4, another 8 pi over 4, and then 1 more pi over 4. That takes me to this point. And then what I want to do is I want to just divide the y coordinate and the x coordinate. Well, the y coordinate and the x coordinate are the same here. So then this is going to be 1 over rad 2 divided by 1 over rad 2. That's equal to 1. And that would be our answer. So really what we're doing is we're dividing out by 2 pi, and we're trying to see what the remainder is, because each 2 pi is going to take us back to our starting point. Okay. All right.